Step into the Coliseum of Cambridge exams. It's intense, it's unforgiving, and the reality is, only the prepared survive. Welcome to this explainer. Today, we're diving deep into the ultimate examiner's playbook, specifically looking at Cambridge Information Technology, Syllabus 9626, AS and A-Level. Our absolute laser focus today is Section 8.1, Creating Formulas. We're talking addition, subtraction, multiplication, division, and indices. But right off the bat, let's open up a real Cambridge computer science past paper, specifically a question from code 0417, and look at a scenario that trips up literally thousands of brilliant, incredibly smart students every single year. Imagine two students stepping into this arena, facing a massively tough data modeling question. First, we have Alex. Now, Alex knows their stuff. Alex overloads the answer sheet with raw computer science facts. They know every mathematical operator inside and out, they can define a function perfectly, but they provide absolutely zero analytical depth. It's just a wall of disconnected facts. Then, on the other side, we have Sam. Sam is fast. Sam sees a formula question, instantly crunches the numbers, gets a final value, but rushes so much that they completely miss the command word requirements. They completely ignore what the question is actually asking them to do with that number. Both Alex and Sam walk out of that exam hall feeling super confident. They think they nailed it, but when those final grades come back, they've missed absolutely crucial marks. It's a gut punch. And listen, whether you're studying syllabus 0417, 0478, 2210, 9618, or our main focus today, 9626, the challenge is exactly the same across the board. You are stepping into the same coliseum. So how do we transform those missed opportunities into top-tier, maximum marks? Let's get into it.
This brings us to a massive, fundamental question. And this isn't just me asking. This comes straight from the senior examiners themselves. Why do students find applying formula concepts to unfamiliar contexts so incredibly hard? Think about it for a second. You already know how to add. You know how to subtract, multiply, divide, and use indices. Honestly, you've been doing that basic math for years. But here is the catch. The exam doesn't just ask you to calculate 2 plus 2. No way. It drops you into a volatile retail business scenario and asks you to dynamically reference cells to calculate a moving average. It asks you to use nested operations and indices to project future growth based on shifting variables. It is the context that trips you up. It's a real-world puzzle. Students spend months memorizing the technical syntax of Section 8.1. They know where the brackets go, but they completely fail to decode the scenario they are given. They freeze up the second the exam removes those familiar training wheels and forces them to build a formula completely from scratch to solve a brand new, real-world business problem. They know the tools, but they don't know how to build the house. And that is exactly what we are going to fix today.
So let's lay out our roadmap to maximum marks. We are going to go through this structured insider look at the examiner's playbook step by step. First, we'll tackle the formula creation challenge. Second, we'll dive into the core principles and theory. Third, we're going to break down the procedural framework. Fourth, we'll reveal the method mark strategy. Fifth, we'll cover the top examiner warnings so you know exactly what traps to avoid. And finally, number 6, we'll master critical analysis evaluation. Let's jump right in. Section 1, the Formula Creation Challenge. We are completely dissecting exactly what Cambridge examiners are looking for when they grade your paper. I really want you to notice the difference here between superficial breadth and analytical depth. Remember our student Alex, the one who overloaded the page with facts? Alex showed superficial breadth. Alex wrote down absolutely everything they knew about division and multiplication in spreadsheets. They practically wrote a textbook definition. But they didn't actually apply any of that knowledge to the specific spreadsheet provided in the exam question. According to the strict foundations of the 9626 syllabus, academic benchmarks require logical, structured reasoning. The assessment framework rigorously, and I mean rigorously, prioritizes analytical depth over just skimming the surface. This is exactly where you need a system. Let me introduce you to the PEAL framework. That stands for Point, Evidence, Explanation, Link. When you are asked to explain a complex index formula you've created, you don't just dump facts. You make your point. Clearly state what the formula does. Then you provide evidence. You actually reference the specific cell ranges in the spreadsheet, like A2 to A10. Then comes your explanation. You detail exactly how the multiplication and division operators are interacting within those brackets. And finally, the most important part, you link it back to the business context. You explain how this formula actually solves the company's projection problem. Let's do a really quick interactive test here. I'm going to give you 2 answers, and you have about 10 seconds in your mind to spot which one follows the PEAL framework. Answer A. I used multiplication to get the total cost for the business. Okay, pretty standard. Now, answer B. To calculate the total cost, I multiply the unit price in cell B2 by the quantity in C2, which ensures that as the retail supply chain fluctuates, the total automatically updates to reflect the new overhead. Which one gets full marks? It's answer B, absolutely every single time. Analytical depth completely destroys superficial breadth. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 2, Core Principles and Theory. Let's build that rock-solid foundation that underpins high-scoring formula creation. Okay, I want to share a massive top marks secret with you, and this comes directly from reading years of principal examiner reports. The absolute secret to unlocking top marks is to reference cross-topic connections. Listen, the theoretical architecture of creating formulas doesn't just exist in some isolated bubble. It doesn't exist in a vacuum. It actually rests on precise definitions, understanding causal relationships, and seamlessly integrating with completely different syllabus areas. The examiners state very clearly that candidates who successfully reference cross-topic connections achieve significantly higher marks. But what does that actually mean for you in the exam hall? It means when you are using basic addition and subtraction in a formula, you need to be consciously aware of how the resulting data types are going to impact a database import later on, or how the formatting of that perfectly calculated value impacts the overall data dictionary of the system. You are connecting the math you just did to the broader, holistic IT system. You are using systematic analysis and evidence-based reasoning. And guys, that is exactly what the conceptual framework of this advanced syllabus demands from a top-tier candidate.
Section 3, the procedural framework. It's time to introduce the strict methodology required for tackling these questions systematically.
Knowing the theory is fantastic, but how do we actually transform a student like Sam, who rushes, does the math, but completely misses the command words, into a top-tier, grade A candidate? You have to follow a strict procedure. Look at these 4 critical steps. Step 1, extract relevant data. Step 2, break into logical steps. Step 3, select your analytical framework. And Step 4, execute with clear notation. We call this the deconstruct, solve, evaluate exam strategy. And it is a total game changer. Imagine you turn the page and see a massive, intimidating paragraph explaining a company's complex financial model. What Sam does is instantly start typing equal signs and brackets, hoping for the best. Do not do that. First, deconstruct. Extract the relevant data. Ask yourself, what are the constants here? What are the variables? Then, break it down into logical steps. Do you need to calculate the gross margin with subtraction first, before you even think about applying division for the percentage? Only then do you select your framework and execute. If you try to jump straight to step 4 and just execute, your formula will absolutely fail. Your brackets are going to be in the wrong place, your indices will calculate based off the wrong base number, and your entire answer will just crumble. Method is everything. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's talk about presentation. Look at the strict conventions required here. Proper headings, correct terminology, appropriate formats, and clear annotation. The practical application of Section 8.1 is all about developing professional IT skills. Let's do a quick interactive challenge right now. Imagine a complex computer science data table pops up on your screen right now. You've got a 60-second timer ticking down in your head. Your goal is just to scan the data and extract the core trend. You see raw numbers, but they represent a company's revenue. Now, imagine you build the perfect formula. It calculates a monetary value using complex multiplication perfectly. But you leave the cell formatted as a general number instead of currency. Guess what? You lose marks. It is literally that simple. You did the hard math, but you failed the presentation convention. Examiners aren't just looking for human calculators. They are looking for polished professional presentation. They want correct terminology and appropriate formats every single time.
Section 4, the method mark strategy. Let's shift to the absolute most crucial safety net in the entire Cambridge exam system. I really want you to let this quote sink in. This is a massive aha moment delivered straight from an examiner alert. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Let's do another mental challenge. I want you to imagine a complex data table showing a business's overheads over 5 years. You do everything right. You scan the data, you extract the core trend, and you build this beautiful, complex formula using addition, subtraction, division, and an index for compounding interest. It's a masterpiece. You hit enter, but the final number is wrong. Why?
because you missed exactly one closing bracket in the middle of the formula. If you just wrote down that final calculated number on your exam paper, you get a 0, completely zeroed out. But if you actually showed your working, if you wrote out this step-by-step logical breakdown of how you constructed that formula, the examiner can look at it and say, okay, this candidate clearly understood the multiplication, they understood the division rule, they just made a tiny split-second syntax error. And because of that, they will award you method marks. Those method marks can literally be the difference between 2 entire grade boundaries. So please, always, always show your working.
Section 5. Top Examiner Warnings. It is time to pivot to the pitfalls and explore the top mistakes directly from the people grading your papers.
We have combed through hundreds of pages of principal examiner reports to find exactly where students bleed marks, and it always comes down to these top 3 critical errors. Warning number 1, confusing cause and effect. Examiners report over and over that students frequently misunderstand how changing a variable in a multiplication or index formula actually affects the final output. If I dramatically increase the exponent, what happens to the curve of the data? Does it go up linearly or exponentially? You need to understand the logic of the business impact, not just the raw math on the page. Warning number 2, forgetting to check format and presentation. We just covered this, but it is so common it needs repeating. If it's money, format it as currency. Warning number 3, answers are not specific to the context given. This is the big one. Let's do a find the flaw challenge. Imagine a student writes this paragraph. I use division to find the average of the costs. Can you spot the sentence losing marks? The flaw is that it is totally generic. It completely fails warning number 3. It's not specific to the context. To get the marks, your answer must be, I use division to divide the total annual server costs by the 12 operational departments in order to accurately allocate the monthly IT budget. Do you see the difference? Context is absolutely king.
Section 6. Critical Analysis Evaluation. We are transitioning to the final and most advanced stage of problem solving. How do the absolute top-scoring candidates evaluate their work? They followed these exact steps. Number 1, they question assumptions. Number 2, they consider different perspectives. And number 3, they justify their decisions with hard evidence. When you solve a problem in Syllabus Area 8.1, you don't just stop when you get a number. You identify the given information, you break it into logical steps, and you solve it systematically. But then, you must take a step back and check for reasonableness. Imagine your formula calculates that a tiny, independent local retail shop somehow made $40 billion in a single week. If you just write that down and move on, you fail. But if you take a second to question your assumptions and check for reasonableness, you'll immediately realize your index operator was wrong. This brings us to the ultimate computer science success blueprint. It's a system of 3 rules that guarantee top marks. Rule 1, command word decoding. Know if you are explaining or evaluating. Rule 2, PL framework application. Always use point, evidence, explanation, link for written answers. Rule 3, time management matrix. Allocate your time based on the marks available, so you never rush like Sam or overwrite like Alex.
To truly master critical analysis, you must explicitly identify limitations, the assumptions you've made, alternative interpretations, and their ultimate effect on your conclusions. When you construct a formula to model a specific scenario, you have to acknowledge its limits. Let's say you built a brilliant addition and subtraction model to project cost for the next 5 years. Ask yourself, does this formula actually account for seasonal inflation? Does it account for sudden supply chain disruptions? If it doesn't, you need to explicitly state that as a limitation in your written evaluation. Evaluating evidence quality means making justified recommendations based on the real world. It means proving to the examiner that you don't just know how to click buttons in a spreadsheet software. You actually deeply understand the messy, complex business reality that the software is desperately trying to model.
Which leaves us with this final, absolutely vital question to ask yourself before your next exam. Are you just solving the formula, or are you actually justifying the context? Because honestly, anyone can memorize syntax and punch numbers into a cell. But a true IT professional, a true top-tier Cambridge candidate, builds a logical system that perfectly reflects the real-world scenario. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here. Keep analyzing, keep evaluating, and we will see you next time.